Hi guys, welcome to another Chelmer Valley Maths tutorial video. Mr. Gordon here. I'm going to be looking at some GCSE topics today, and at the time of filming this, the GCSE exam is only a matter of days away. So I'm not going to be looking at them in a very sort of, mathsy sort of way. What I'm going to be doing is I'm going to be trying to come up with some silly ways and some fun sort of stories or things that help you remember what to do when you see certain topics. And the topics I'm going to be looking at are ratio, nth term rules, the cumulative frequency, we're plotting it mainly, and vectors. There's always a mark on a vectors question that we can try and get, and transformation of graphs, and that's normally one of the last few questions, maybe the last question on the test, and there are some marks there generally. So I'm going to be using this anchor symbol here to try and direct you towards the part that is the bit I want you to remember, the silly thing I want you to hold on to hopefully then when you're in the question it'll be in your mind, and then the cogs will turn and you'll think, right, oh yeah, I remember what Mr. Gordon, that stupid thing Mr. Gordon came up with to jog my memory. So let's start with the first topic, and that is ratio. So the anchor is up here, you can see it's in the title, so I've written it as ratio O, okay, and those zeros are important, so you have to kind of say that stupid saying to remember what to do with ratios. And let's have a look at a question then, quite an easy basic one to get started. So a piece of wood is of length 45 centimeters. The length is divided into the ratio of 7 to 2. So the wood should be divided, I suppose, into 7 to 2 if you're sawing it like this. Work out the length of each part. So the ratio O comes into action here because I've got 7 parts of my ratio here and 2 parts of my ratio there. So I draw a circle, or an O, a circle for each part of the ratio. And so I've got 7 circles there. And on the other side, the right hand side, I've got 2 circles for my 2. And that shows me how much, what I need to divide my 45 centimeters, the whole piece of wood, into equally. So there are 9 parts of the ratio in total. There are 9 circles. So what is 45 shared between the 9 circles? Well, 45 divided by 9 is going to give us 5. So each part of the ratio is worth 5. Each circle is worth 5. So let me just quickly put in these 5s, and hopefully you can start to work out the length of each part of the piece of wood once it's been chopped up into these 2 ratios. So into these 2 sections, sorry. So you can see if I put a 5 in each one, it becomes really obvious, doesn't it, how long the longest piece of wood is, this part here, and how long the shortest piece of wood is. So then what we do is add up the circles and we will get the length of each piece of wood. So there we are. We've got 2 5s 10 centimeters, and then obviously we've got 7 5s there, 35 centimeters. So I want you to have a go at a couple of questions using the circle method and just see how it goes for you, okay? So here are the questions, and I would recommend you pause the video now and then have a go at these, come back and we'll go through the solutions. Okay, hopefully you've had a go at these questions. Let's have a look at the first one. So we've got number 1, we've got Amy, Beth and Colin share 36 sweets in the ratio of 2, 3 to 4. So the first thing you would do is draw your circles, 2 circles, 3 circles, and then 4 circles for Amy, Beth and Colin in the same order. So work out the number of sweets in each one. So you divide the 36 sweets between how many circles? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 36 divided by 9 gives you 4, hence I put 4 in all the circles, and then you just add them up. So Colin got 16 sweets, Beth was in the middle, she got 12, and Amy got 8. Hopefully you got that right. The second question was a bit it was a bit different, and once you learn how to do it, it's not actually any more difficult than the normal one. So Rosa prepares the ingredients for pizzas. There she is, baking away. She uses cheese, topping and dough. So 3 ingredients there, cheese, topping and dough, in the ratio 2, 3 to 5. And they come in the same order. So the first one is cheese, and I put 2 circles there to represent the 2. The middle one, sorry, was topping. That's got 3 circles. And the last one was dough, and that's got 5 circles. And it says Rosa uses 70 grams of dough. So it doesn't tell us what all of this is worth. It just tells us what the dough is worth. The dough is worth 70. Well, how many circles did the dough have? And the dough's got 5. So what is 70 divided into 5 circles? Well, 70 divided by 5. If you do 5 times 7 up to 70, it's 14. So if I put 14 in those circles, then I know what all the circles are worth. If one circle's worth 14, they're all worth 14. So fill them all in with 14s. And then you can add up the other two. So these, for the topping, these 3 here, 3 14s are going to add up to 42 grams. And then for the cheese, you've just got to add up 2 lots of 14, which is 28 grams. Okay? Hopefully you got those right. So the next topic is going to be nth term. So hopefully you didn't have the volume up too loud for that bit. So the reason why we've got a dinosaur on the screen is because the anchor for this one is the word dino. And I'm going to explain to you what this means and why I've written it in certain colours. So let's have a look at the word dino. Well, how does it help us with nth term rules? So up on the right hand side here, we've got the word dino. And the DI in the front of the N is for the difference. So when you're given a sequence, it's the difference between the numbers. And we'll have a look at doing that in a minute. The green 0 on the end, so or the O if you like, but we call it it's the 0 because it's the 0 term. And we'll look at how we find the 0 term of a sequence right now. So let's have a look at this question. The first 5 terms of an arithmetic sequence, which just means you're adding up something each time, goes like this: 6, 11, 16, 21, 26. Find an expression in terms of n for the nth term of a sequence. So find the nth term rule. I've rewritten the sequence down here. So the first thing my dino says is find the difference. So the difference between each term, well, the difference between 6 and 11 is going to be 5. And the difference between 11 and 16 is going to be 5. And that's going to be 5 all the way along. So the difference, we can see, is just 5. Okay, so it's a plus 5. Going up in add 5, so it'll be a plus 5. Difference is plus 5. The 0 term, well, if this is the first term, this is the second term, this is the third term. So let's go backwards. This is the third term, this is the second term, this is the first term. What comes before 1? 0. So the 0 term is the one before the first one. So what would that be? If I'm going backwards, I'm taking off 5, and then take off 5 again, and I'm going to get plus 1. I'm going to get a 1, so a positive 1. So that would be the 0 term, the one before the first one. So then let's use these answers to set out our rule. So right, the first thing we need to do is put the difference. Well, what was the difference? The difference was 5. So let's put the 5 up there. Then we need the n, because the n's in black. So 5n, difference goes right next to the n. And then the 0 term, well, what was that? That was the plus 1. So that is the bit that goes on the end. And there is your nth term rule. 5n plus 1. 5 times n plus 1. Alright, so I want you to use the dino memory technique to have a go at some questions. Here are the questions. And pause the video, have a go at these, and then come back and we'll look if you got the correct answers. Okay, hopefully you had a go at those. So, first one, what's the difference? We've got to work out difference first. Well, the difference from 2 to 9 is 7. Just check it, it's 7 again. So 9 to 16, yes, it's 7. And the 0 term, well, this is the third term, second term, first term. Where's the 0 term? Well, it's before the first one. What are we subtracting each time? Well, if we're going up in 7s, if we go backwards, we're going down in 7s. So what's 2 take away 7? It's going to be minus 5. So if you write out the rule, you should have got 7n minus 5. The difference is 7. The 0 term is minus 5. Second one, what's the difference here? Well, it's 5. And what's the 0 term? What would be before 2? If you're taking off 5, it would be minus 3. So your answer for that one would be 5n minus 3. Okay, so the next topic is cumulative frequency. And we are going to draw a cumulative frequency graph here. So we've got the frequency table, and it's filled out for us. And we've just got to fill out the cumulative frequency table. So I've got up here the anchor. What I want you to remember is the word cumulative is a bit like, and a bit sounds like, the word accumulate. Okay, and I'm going to think of a situation that most of us can relate to about accumulating something. And the one that's proved most popular over the years with my students is accumulating clothes on your bedroom floor. So what I want you to do is think about each group. So the first group here as a day. So like Monday, Tuesday, Wednesday, Thursday, and Friday. And these are the number of things you're going to drop on the floor. So let's have a look. On Monday, after Monday's happened, at the end of Monday, you've got 12 items of clothing that you've dropped on the floor throughout Monday. As Tuesday ends, you've dropped another 15 on the floor here. And on Wednesday, you dropped 18 bits of clothing. So start to get really messy now. And then on Thursday, you've dropped a further 12. And by Friday, you're almost running out of clothes to drop. So you've only dropped 3 items of clothing on the floor. And all we've got to do is keep a running total about how messy the room is throughout the week. So on the Thursday, how many bits of clothing did we drop? At the end of Monday, by the end of Monday, we dropped 12 on the floor. By the end of Tuesday, how many items of clothing were on the floor? Well, we've got the items from Monday, and we've added 15 extra on the Tuesday. So if we add those up, then the total number of clothes on the floor is going to be 27. By the end of Wednesday, how many bits of clothing were on the floor? Well, look, here's the first 3 days, 12, 15, and 18. How much is that altogether? Well, that's going to be 45 if we add those up. By the end of Thursday, we've dropped a further 12 on the floor. So again, all 4 days added together, a massive pile of clothes. 57 items of clothing are on the floor. Okay, Mum is going to go mad. So the last day, we've only dropped a further 3, and that's pretty much our whole wardrobe now. We've got a floor wardrobe of 60 items of clothing. And then we need to plot this on the graph. So, and a way to, I like to think about this, if people are really struggling to get this right, is, right, when does Monday end? Monday ends on 30. All right, the end of Monday is the 30. So at 30, we have dropped 12 bits of clothing. So I reckon it's going to be about here somewhere. And when does Tuesday end? So at the end of Tuesday, 40, we had 27 on the floor. So at the end of Tuesday is 40. How many bits of clothing on the floor? Well, 27. So it's somewhere up here. I'm going to do this very roughly because the graph is not particularly easy to read on the computer. At the end of Wednesday, well, when does Wednesday end? Wednesday ends at 50. And there were 45. So let's go from 50 up to 45. So 45 is going to be somewhere around here. And then we've got Thursday. At the end of Thursday, we've got 57 items of clothing. So Thursday ends at 60. So go to 60 and all the way up to 57, somewhere about here. And then finally, we've got Friday. Friday ends at 70, and there are 60 items of clothing. So let's go to 70. That's the end of Friday, all the way up to 60. And there it is, just about somewhere about there, okay? So what do we do at this point? Well, we would freehand a nice smooth curve to join all of those up. Unfortunately, I don't have that facility here, so I'm going to have to do it with straight lines, but you don't use straight lines, you just do a nice smooth curve. But it will look something like this once you've finished, okay? So something a bit like this, and then normally there's some other questions you can go on to answer. But once you've got the right graph, the other questions aren't too bad. So I'll give you an example to have a go at. Have a go at this one, and then come back and I'll go through the solution with you. Okay, hopefully you've had a go at that. And the solution is adding up all of the things as you go. Looks like this. And then the graph looks something a bit like that. So again, I would recommend a smooth curve, nice smooth curve, freehand all the way through. And then you can go on to answer the other questions to do with the graph. Okay, on to the next topic, vectors. And I want you to think of vectors as like directions on a road map. So the anchor here is on the road sign. So think about this as like directions on a road map. So how does it work? So you can only travel down the roads with arrows on. That's the first rule. So this road is no good, okay? There's no arrow on it, so we can't drive down it. You can drive either way down the roads with arrows on, if you go with the arrow, you're going to call it a plus something. So for this road here, the road's called A. So if you go this way down it, it'd be a plus A. If I wanted to come back up it, you'd have to call it something else. And the opposite to plus A is minus A. So if you go against the arrow, then you're going to have to say minus A. Okay? And if you go down here, that would be road plus B. And if you went the wrong way down it, you'd be calling it minus B, going down this way. So let's have a look. What does it say? Right, find the directions from town A driving to town B. So A, you can see the arrow, it goes from A first, then to B. So let's get the car out and see what the instructions are. So I'm at A, it says start at A, that bit there says start at A, drive to B. So what are the directions? What would you tell me if I was in the car and I said, right, how do I get from A to B? I want to go down this way. You say, right, you can't go down there because there's no arrows there. I say, okay, is there another way? And yes, there is. So I can drive down here. So what is that direction? Well, I went against the arrow. So that would be a minus A. And then followed by, when I get to here, I need to go up this road here. So I drive up here, all the way up the road. And then I get to my destination, town B. So I went minus A and then followed by a plus B because I went with the arrow. Okay, so the answer to that would be, the directions are minus A plus B. So see if you can follow that again. You start from A because it says A driving towards B. And I drive down here. That's the minus A bit going against the arrow. Get to this corner, skid round there, and then off we go. Plus B with the arrow all the way to town B. Okay, so using those rules and that idea, I want you to see if you can have a go at this question here. You're going from town P, driving to town B. So start at P, drive to town B. And remember, you can only go down the roads with arrows on. Pause the video, have a go at it. Okay, hopefully you had a go at that. Let's get the car out and see where we stand. So, we start at town P as given by the instructions here. Start at town P and drive to town B. So I'm going against the arrows here, and I've gone minus B there, and then I've got an extra 2B there to get me up here, round the corner, handbrake turn, and then I'm going with the arrow here along to B. And that was an instruction of plus A. Went with the arrow, and it was plus A. So the answer, hopefully, that you got was minus 3 plus A. So let's do that again. Start at P, minus 3, down against the arrows, down here, round the corner, with the arrow, plus A. There we go. I got from P to B. One more for good practice. So, have a go at that one. Pause the video. Hopefully you've had a go at that. Let's get the car out and see what the instructions are. So, where are we going now? Well, instructions say, let's drive from A to town B. So here we go. I'm starting at A, and I'm going to drive to town B. Now, I could go down this road, but there's no arrow, so no good. Shortcut, right through the middle, looks good, but no arrow, so can't use that road. I've got to go against the arrow, and I'm going to do 3A, so it's going to be minus 3A. Against the arrow, here we go, minus 3A. And then from there, I'm going with the arrow, so it's a plus 6B. Up we go. And then I'm at town B. So the instructions were minus 3A first, then plus 6B. Hopefully that's helped you out, and you can start those questions now and get that extra mark. Nobody wants to be the student who's 1 mark off a C, 1 mark off a B, 1 mark off an A. So every mark we can get is important. Okay then, right, the final topic. Now this one is like the A-star topic at the back of the paper. Some of us might never even look at this, but I want you to have a go at it. If you see this type of question, let's have a go at it, okay? Let's get a couple of marks. So, this topic is to do with, normally you've got some sort of curve and there's a coordinate given to you on the curve. So it says the diagram shows part of a curve with the equation y equals fx. Now what does that mean, fx? Well, what does it sound like? It sounds like the word effects, okay? So I'm going to teach you some rules to what's called the effects game. So how do we play this game that they've set out for us? Well, there's only 2 rules, and it basically says, you've got to look for the instruction first. So the first question gives us an instruction here, and the 2 rules are, if the instruction is inside the bracket, it only affects the x part. So hopefully you know which one of these is the x coordinate. If you don't, Remember, along the corridor, that's the x part. Up the stairs, that is the y part. So the x coordinate is always first, the y is second. I put it up here to remind us which part is which, okay? So back to the rules. If the instruction is inside the bracket, it will only affect the x coordinate, but you must do the opposite to what it says, okay? Got to remember that. If the instruction lives outside the bracket, it will only affect the y coordinate, and you do what it says. Alright, so those are the two rules. Let's see if we can play the effects game and get some marks. So, what's the instruction? Well, have a look at that. Well, what do you think is the instruction here? Well, actually, it's the -2. That's the instruction we're given. -2. Let's subtract 2. But from what? Let's go back to the rules. It's inside the bracket. The -2, look at it. It's inside the bracket. And look who's in there with it. The x. So, instructions inside the bracket only affect the x coordinate. You must do the opposite. Well, it's telling me to subtract 2 from the x part. Well, I'm not going to do that. I'm going to do the opposite. I'm going to add 2. So look, my x value here is 2. And if I add 2 to it, because I'm doing the opposite, then I'm going to get 4. So for that question, I get 4. There was no instructions outside the bracket, so the y value stays the same. Not too difficult, is it? Let's have a go at another one. So, the instruction on part B is this 2 outside the bracket. Can you see it? It's not a +2, it's not a -2, it's just a 2. There's no sign with it. What is it doing to the fx? If you know algebra, when things are next to each other, they are multiplying. So that's multiplying by 2. If it's outside the bracket, it will only affect the y coordinate. And do what it says. So, it says I've got to times the y coordinate by 2. And that is what I'm going to do. So, the y coordinate is the second one, the 3. It says times it by 2. Okay, that's 6. There was no instructions inside the bracket this time, so I leave the x coordinate alone, and I leave that as 2. Hopefully, you've understood the rules, and with the rules, can you play the game? Let's find out. Here's an example for you to have a go at. So, pause the video, have a go at this example. You've got your coordinate there, 3, 1. You've got the rules down here. Have a go. Hopefully you've had a go at that. Let's have a look and see if you've got those right. So, part A, the instruction is outside the bracket and it's a +3. If it's outside the bracket, rule number 2, it only affects the y coordinate. Do what it says. Right, so I'm going to add 3 to the y value. Well, the y value here is 1. If I add 3 to that, it's going to give me a 4. So that's 4. There was no instructions inside the bracket, so the x part remains unchanged. On to B. Well, we've seen this one before, haven't we? We've got a -2 inside the bracket. If it's inside the bracket, it will only affect the x coordinate. Do the opposite though. So don't subtract 2 from x. You've got to add 2 to x. Well, x is 3 at the moment. Let's add 2 and we're going to get 5. If we've got 5 there, no instructions outside the bracket, so we can leave y alone, just 1. Part C. Now we've got a strange one here. We've got the instruction inside the bracket. It's got a half x and it's right next to the, it's got a half right next to the x. That means it must be timesing. So, timesing by a half. Let's look at the rules. It's inside the bracket. It will only affect the x coordinate. Do the opposite. So don't times it by a half. Divide it by a half. So what's the x coordinate? 3. Dividing it by a half means how many halves go into 3? Well, I know 2 halves go into 1. So that means 4 halves go into 2. 6 halves are going to go into 3. So there we go. That's 6. And there was no instructions outside. So the y part is still 1. Last chance to have a go. So here we go. Last one. This question is another interesting one. Be careful on part 2. I'm going to let you have a go first. Pause the video and I'll go through the solutions in a minute. Hopefully you've had a go at that. Let's have a look. So this is a popular rule, isn't it? They like this one. So again, we've got -2 in the bracket. We know now that means it only affects the x, and we do the opposite. So we're adding 2 to x. Well, x is 3. So if I add 2 to x, it becomes 5. And then I don't touch the y. No instructions outside, so -4. Part B, very interesting here, we've got two instructions. Okay, so one is inside the bracket, the +5. What happens now? Inside the bracket only affects the x, do the opposite. So I'm not going to add 5 to x, I'm going to subtract 5 from x, and x is 3. So 3 take away 5 is -2. And I've got another instruction, I've got 2 this time. So adding 6 is outside the bracket, it will only affect the y, do what it says, add 6 to y. Well, what's -4 add 6? It's going to give me 2. Okay, so hopefully that has given you a chance now to have a go at those questions. I want to do one more actually, I did lie. This was the last question on paper 1 last year, 2015. Here it is, okay? So this was the very last question on the test last year. Do you think you can have a go at it? Pause the video, see if you can write down the answers. Have a go. Right, hopefully you've had a go at that. Let's take a look, see how you did. So, part A, the instruction says +3, it's inside the bracket. Where's the coordinate? 3, 5 is the coordinate we're playing with this time. What effect will this instruction have? Inside the bracket only affects the x, do the opposite. So I'm not going to add 3, I'm going to take away 3 from the x part. So 3 take away 3 is 0. Don't touch the y, no instructions outside. We've got a 5, leave the 5 there. This one, we've seen this before. 2 on the outside, it's right next to it, it's multiplying. So outside only affects the y, do what it says, times the y coordinate by 2. So the y coordinate's 5, it now becomes 10, doubled. The x coordinate, no instructions for that, so leave it the same. And finally, we've got 3x inside the bracket. We've got 3 there. It's not x plus 3, it's 3 times x inside. So inside the bracket will only affect the x coordinate. Do the opposite. What's the opposite? Timesing by 3, dividing by 3. Now luckily for us, the number we've got to divide by 3 is 3. 3 divided by 3, very straightforward. Once you know what to do, that is just 1. No instructions outside the bracket, so we can leave the y coordinate well alone, and that's 5. Okay, so remember, that was the last question, part of it at least, on the higher GCSE 2015 paper. If you can do that, it just shows you, with a little bit of a memory technique or something like that, you can actually have a go at some of these questions that you might not have been confident enough to attempt before. So I hope that's helped you. Best of luck in the exam, and please check the website for more videos.